All right. I took a while on this one, but I came up with a solution. Not the solution. The runtime's decent. The memory's not so. And that's because it uses a queue to keep track of things. But I think it's actually a pretty good use of a queue. But here's what we got here. So, given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So we have this. So like for example, we have this right here, and we have four ones in a row, and we can use the two k to flip the two zeros around it to make a stretch of six. So we should return six. So at first I was thinking, gee, well, like to brute force it, which I knew wouldn't work because it would take too long. But basically, you go through every index, and then you see how long you can go before you encounter k zeros, or k plus one zeros, because even when you reach your last zero, like even if k is only three, you can still tack on the ones that are beyond that last zero. So you could, it's really up to this. The problem is that's O(n) squared time, and these numbers get really big. The num's length can be 10 to the 5. So O(n) squared time is just not going to work because it's for every index you're going through possibly the entire array. So it's O(n) squared time. I came up with something that's much better. It's actually just what was it? It should just be, sorry, submissions. This is O(n) time because it just does one pass through. And it's not the best memory because it makes use of a queue, which I think will is what's costing me the memory here. But here's what we do. First, we check to see if we even need to do anything. This sure, so count zero will cost one pass through, but it's just O(n), and it handles it cuts out a lot of issues. Um, like what if they're all, I mean, I guess we could just I don't even think, I guess we don't really, do we not need that? It still works. Is that faster? I mean, relatively. Okay, so okay, sorry, I should explain more before I go about it. Basically, that right there was just a little check that I was using to say, okay, well, if there are fewer zeros than there is k, then you can just flip all of the zeros, and bam, you get just a streak of pure ones. But that's only a few cases. I don't think it's worth checking all of the zeros, while counting through the entire array to count up those zeros. So what I do instead is this. I realized that the what matters is not counting everything. It's counting the largest distance between k plus two zeros. At first I thought it was k plus one, and then I realized it's k plus two. Let's say that k is two. So we're looking for the largest distance between k plus two zeros. So if k is 2, then k plus 2 is 4. So now we go through this and we see, okay, we see 1 0, we see 2 zeros, 3 zeros, and then 4 zeros. So we can just take that minus 2, or actually minus 1 because of how we do the index. How that's, yeah, the index is 0, 0 indexed. And we get, this is a 5, this is a 0. So it's 5 minus 0 minus 1 is 4, which is the 4 in between. So it's as if you were put a 0 here and here. And then what's nice about this is then you can hold on to that data. So instead of having to then go back to the next value and going from there, you can just you can just shift the window to the next 0 and say, okay, well, we'll start from here. And then once we encounter our fourth zero, or sorry, we're not starting from there. We are just lopping off that first 0, and now we're back to 3 zeros. And we work our way until we see our fourth 0. And so we know that it's these right here, and you can kind of see that because we fill in these zeros right here. So it's basically the two enveloping zeros around the streak of ones where you flipped two zeros within that range. Um, so the way we do that is we have a queue, and we start the queue with a value at -1. The -1 is to account for what if it starts at 1. You want to make sure that you're counting those values. So you count that as essentially a 0 because it is a bounding value. So you say, okay, so we have -1, and you go, let's say k is 1. So we have -1, and then we see 1, 2. So the well, then we see so we have -1, and then we have 2, 3 zeros with quotation marks, and then we get 1, 1, 1, 1. Then we flip this 0 to a 1. We get 4. So that's -1. Well, sorry. 4 minus -1 minus 1 is 4 plus 1 minus 1 is 4, which is this. Anyway, so yeah, we have this queue, and if we see a 0, then we append a 1 to that queue. We append that index to that queue. And then if that queue is now a length of k plus 1, then what we do is we pop off that last value, and we see the distance between the k plus 2 0 and the last value, and then we account for that extra 0 with a -1. And then we just set that the max length. We do max length, a little king of the hill thing. We do one time at the end to basically same thing of how we account for the starting part. We do the same thing for the end. So we do the same thing as if the ending thing was a 0. By saying length of nums instead of the last number in the queue. So I hope that makes sense. I'm very tired. I'm staying up way too late because I was working on this. Well, not working on this, just working in general. I should let myself relax. Yeah, but there we go. Thanks for watching.